All right, welcome to the first of our, what looks like it's going to be 3 makeup lectures. This is to make up for the technical difficulties we had connecting with Bremerton last week. So I've got 3 makeup lectures I'm going to present. I'm going to ask you to remember that on Monday, before all of these technical issues, we had been discussing hypothesis testing when you do not know the variance of the original population. If you did know the variance, we'd go ahead and we'd just use the normal distribution, and we'd been working on that for the last few weeks. This is the question of, all right, so what if you don't know the variance, and also if the sample size is fairly small. So if the sample size was large, we'd just go ahead and we'd use the a normal distribution with the normal distribution with the and then just take the variance of the sample as the variance of the population. But if the sample size is small, we can't do that. So I want you to recall that instead of using a normal distribution, we're going to use what's called a t-distribution. So hopefully you've looked at your notes from Monday and you remember, so if I want to use this t-distribution, perhaps on a 2-sided t-test, and for hypothesis testing, I might say something like my null hypothesis, mu is equal to some mu naught. My alternative hypothesis is that mu is not mu naught. And now, instead of having a normal distribution, I'm going to have a t-distribution. So the t-distribution I have, my test variable is now going to be t x bar minus mu naught. And now, instead of the variance of the population, I'm going to use the variance of my sample, where S is defined as 1 over n minus 1 xi minus x bar squared. Okay? And to refresh your memory, now what I'm saying is that I have a t-distribution which looks similar to a normal distribution, and just like with the normal distribution, I can start making statements like, for some given alpha, this is 1/2 of alpha, this area is still 1/2 of alpha, and I can make statements like this. Now we're going to call this point t a n minus 1. This will be minus t a n minus 1. And I can start making statements like we will reject h naught if the sample size I get is outside of this area, because it implies that if this was the true value, if mu naught was my true mu, then I would probably find a value for my sample sometime where in this area, not out on the edges. All right, so let's go ahead and do an example. All right, so in the example I'm going to give, there's some biomedical device that has an approximate normal distribution. And we have taken samples of n equals 15 samples, and we found that we found that the mean of our sample is 5625.1 hours, and we found that a standard deviation of our sample of 226.1 hours. And we're asked, with an alpha of 0.05, to test the hypothesis that mu is greater than 5,500 hours. Okay? So what I can do is I find my test statistic, and I will find that T naught is equal to mu naught over S over the square root of n. Plug and chug is equal to 5625.1 minus 5500. 226.1 over the square root of 15 equals 2.14. All right, so what I have found then is a value on my t distribution of something out here, 2.14. Now I'm asked to reject if this is further away than what I would expect with an alpha of 0.05. So then I need to find t of 0.05 comma 14. Why the 14? Because when we look at the t distribution, remember we're looking not at the sample size, but at the number of degrees of freedom, which is the sample size minus 1. And to get this value, I go to my t distribution chart, and I look down along this side until I get to 14, which is my number of degrees of freedom, and I look along the top until I get to 0.05, and I go down until I get to the one in the middle, which is one of those values right there. It's a little hard for me to see on the screen, but I get a value of t 1.61. So this value here in this example is equal to 1.761, but I'm further away from that. So I am going to reject H naught in favor of H1. All right. All right, so that was the little example I wanted to do. I did this at the very beginning of class on Wednesday, which you didn't see, before moving on to our next topic. So this is the end of Makeup Lecture 1. I'll see you in a few minutes when you go onto YouTube and look at sample lecture number 2.